Okay. So coming to Newton-Raphson method, I'll be discussing a different problem on Newton-Raphson method. But before going to it, there's a recurrence relation for Newton-Raphson method. I would like to make a mention of what's the origin for the recurrence relation. Newton-Raphson method is also called method of tangents. Method of tangents. Okay, why it is called so? Let us see why it is called as method of tangents. Okay, now y is equal to f of x be a smooth curve. Smoothness a continuous curve. No discontinuities are there, whether they are finite or infinite. I don't want any discontinuities in the curve. It's a smooth curve. Consider a point P x naught y naught on the curve. The equation of the tangent to the curve passing through the point would be given by, all of you know it. What that is y minus y naught is equal to the slope would be what? Slope is what? Dy by dx. Dy by dx, right? It is also denoted by m. Dy by dx from this, what I'll be getting is f prime of x. And I'm considering at the point x naught, so it would be f prime of x naught, right? So f prime of x naught, f prime of x naught into x minus x naught. It can be, of course, if I have 2 points, y2 minus y1 by x2 minus x1. This value can also be written like this. Okay, but whatever is the information that I have, from that I am writing it. Okay, now also y naught is nothing but f naught, right? F at x naught, right? So what I can do here is y minus f of x naught, I can rewrite f prime of x naught, x minus x. Now, just see here, there's one statement, y is equal to f of x. F of x is the equation of the curve. So, equation means what? Equated to 0. If I substitute the same thing in the place of y, what I'll be getting would be minus f of x naught is equal to f prime of x naught into x minus x naught. I'll tell you the geometrical interpretation as well. Okay. Yeah. So, x minus x naught would be what? Minus f prime, you can stop here only, minus f of x naught by f prime of x naught. Okay. Yeah. Suppose if I bring this x naught towards this side, what will be that value? It would be nothing but x naught minus this. Okay. Or I will write properly what that is let x1 be the first approximation to the root. Be the first approximation to the root. Usually, Newton-Raphson method is used to find the root of an algebraic or a transcendental equation. All of you are aware of approximation to the root. So I'll rewrite this as x1 is equal to x naught minus f of x naught by f prime of x naught. Okay. Now, since I have got x1 to be in terms of x naught, I can write it as a recurrence relation, that is xn plus 1 is equal to x1 minus f of f of xn by f prime of xn. Newton-Raphson runs completely on this recurrence relation only. Okay. Now, what's the geometrical interpretation for this Newton-Raphson method? Just see. I have a curve. I'm telling that it's tangent method. Why it is tangent method? Let me show you. Suppose if this is my point, with initial point that I'm considering. Okay. Now what I'll do is I'll draw a tangent at the point P. Now what happens? This point intersects x-axis, right? That would be my first approximation. Now next what I'll do? I'll trace this point on the curve. Again, I'll draw a tangent. Again, I'll draw a tangent. And the second intersection of this tangent with the x-axis would be my x2 approximation. And slowly you can see wherever the curve touches x-axis, that would be my actual root, right? Slowly, I'm converging towards the root. Okay. And then, of course, Newton-Raphson method is of quadratic convergence, guys. So it converges very, very fast. Quadratic convergence. Okay, now coming to a different problem on Newton-Raphson method, I can just, you can be asked questions like this. What that is find the square root of a number. The square root of a number n, and hence find root of 12 or something, randomly something, find root of 12 using Newton-Raphson, not using calculator, by the way, Newton-Raphson method. Okay, what do I do? NRM method. What do I do? Just see here. Now I'll be getting the root of a number, right? Root of a number, square root of a number. So nth root also can be asked. Root n it is. What will it value be? I don't know. So anything that I don't know, I'll be assuming it to be x, right? Yes. Now next what? See here, first to apply Newton-Raphson method, I need a function f of x, right? Or a curve f of x. So I'll be rewriting like this. X minus root n is equal to 0. This would be my f of x. X minus root n is equal to 0. Now if I take the derivative, what happens? X derivative is what? 1. Root n will be a constant, so its derivative would be 0. So if you observe, f prime of x naught, f double prime of x naught, f prime of x1, anything you put in f prime, its value doesn't change. F prime of x1, f prime of x2, nothing will change. All values will be 1 only. Then what's the use of taking this term in the denominator? Instead, I can directly write x0 minus f of x0. Now, so no contribution from the denominator, for which I'll rechange or reconstruct my, what I'll do? I'll reconstruct my function f of x. I'll make a small change so that there's a contribution from the denominator as well. And this is the key point to this problem, guys. If you don't remember this, whatever you do, you will land up with an error. Okay. Whatever you do will go waste, actually, to say. Okay. So what I'll do here, instead of taking x minus root n, what I will do here is I will square on both sides. I'll be taking squaring on both sides. So I'll be having, if it is nth root, I'll be taking power 1 by n. Okay. X square is equal to n. Or x square minus n is equal to 0. Now, this is my f of x. Let's see whether it's working out, whether there's any contribution from the denominator or not. X square minus n is my f of x. So what do? Always remember this point. Again, I'm stressing on it. Remember this point, because otherwise, all your effort will go waste. Okay, f prime of x is 2x. And now contribution from the denominator is there as x values change from x0, x1 and so on. Okay, now let me write the formula. Okay, xn or xn plus 1 is equal to xn minus, he'll be asking you for a recurrence relation as well, f of xn by f prime of xn. Okay, so xn, I don't know as of now, minus f of xn is what? X square minus n by f prime of xn is what? 2xn. Okay, wherever x is there, I'm putting xn. Now you see, guys, what's the root of 9? Root of 9 is 3. Next, what's the number that has a square root? That is 16, right? It is 4. So between 3 and 4, only 12 can be there, na? So what I will do, I will choose my interval to be 3 and 4. Okay. Any point I can take. Usually, for any problem, you will be given the initial approximation. X0, the initial approximation would be given in the problem. Okay. Here, either I can choose 3 or I can choose 4. Or if you are even more smarter, you can as well choose the midpoint of 3 and 4. That is 3 plus 4 by 2. What's it? 7 by 2, which is 3.5. I can choose this as well. Anything is fine. I'll go with 3 as of now. Okay. Anyways, Newton-Raphson method converges faster. Let x0 be this. I'll be assuming. So x1 would be what? x0 minus f of x0 by f prime of x0. I can find a recurrence relation, rearrange this and get the value. And in this recurrence relation, any number I can substitute. And then I can get the square root for any number using this formula. Okay, that's one version. Another version is directly take where the root lies between for 12. What's the interval for 12? And then proceed. Okay, so this would be what? Xn squared. Okay, plus n in the numerator. In the denominator, you have 2xn. This would be my recurrence relation. Okay, I can directly put the values in the recurrence relation. Now, what is x0 that I have chosen? I have chosen x0 to be 3. Okay, what would be f of x0? What's n? N is 12, right? Okay, so f of x naught, f of 3 would be what? 3 squared, 9 minus n is what? 12. So I'll be having minus 3. Okay, minus of minus would be plus. Now f prime of x naught is what? 2x. F prime of 3 would be what? 6. So I'll be proceeding accordingly. 3 plus 1 by 2. This is equal to 7 by 2. Okay, so it would be 3.5. The first approximation to the root would be 3.5. I would have started as well with 3.5. Okay, x2, what I will do is, I will take 3.5 minus f of 3.5 by f prime of 3.5. Use your calculators, find the answer and get the value. Okay, get the value for the root. That's how you will do it. Okay, I will do one more problem, but this is a different problem on Newton-Raphson. Always an interest for the examiner. It can be asked for 2 marks as well as for 3 marks. Okay, so do check this problem, guys. It's very important. It's a different one, by the way. Where is the play? Where do you lose the track is in formulating your f of x. Okay, if you go in a wrong formulation, then all your process will go waste. Okay, thank you.